After setting our assumptions, let's now reflect the material properties, thickness, and other properties on our structure. So first and foremost, we have to make sure that we are choosing the correct job preferences. So you go here on tools and then job preferences. And then from there, you have to make sure that your materials, which is over here, is set to Eurocode, which is the code that we are using. And don't worry about these properties here at the moment, because later on we will be defining element by element. Right, so you also have to make sure that the design code that you're using, especially this is RC structures, should be up to date or should be aligned to the design codes that you're using, which we set up early on to be Eurocode. All right, and then if you are going to do the same model in the future, might as well hit this save current parameters as default so that you will not be defining over and over again. If you're sure about everything, then hit OK. Okay. Let's now create thickness of wall and thickness of slab by choosing this icon over here. Right, so normally there is one thickness specified over here, which is actually the default thickness, but we have to create according to the thickness that we've just provided early on. So for this one, let's just say wall with a thickness of 350 mil, and the property is 3545, which is correct. And for the slab or slab on grade, we have 350 mil. It's the same. Why can't we use the same thickness as the first one? That's because we're going to use this function over here, which is parameters of foundation elasticity. This is where we provide the soil subgrade modulus that we've just shown previously, right? So if you hit this one, it will show you a box dialog where you need to specify your K sub Z. Your K sub Z is 7,000 approximately kilonewton per cubic meter. And rule of thumb, if you don't have values for Kx sub X and K sub Y, which is actually the horizontal soil springs coming from your geotechnical report, you can just specify 50% of your vertical spring. That's around 3,500 kilonewton per cubic meter. And that's it. So now you have slab and wall thicknesses, right? So from here, we have to specify on the model. I suggest you go to properties. We can actually do it here, but these elements are joined. It's because I did some polyline revolution or something like that. So it's better you go here on properties, because here you can actually select specific elements or part of the elements. All right, so for slab, we will select this area over here, which is polyline side 4, and hit OK. Also here, we will select polyline 3 and hit OK. Right, and then the base, hit this one and select side. No. This should be the polyline. And click OK. Right, and for wall, this is your slab. You have to hit this one over here and then click this one. That's it. And for this one, you will select side 2. Okay, so that's it. And you can also delete the unused one, but keep it as it is for now. So after you define the thickness, you can go over the geometry again, and basically, if you want to see the applied thickness, you can go to display, and then panels FE, and then panel thickness over here. It will basically show the thickness you've applied. There it is. Now we are going to create loads. I'll just remove the panel thicknesses of now for the meantime, and then we are going to define now the different loads or load types, right? So we've got the self weight first. This will be the dead weight of the structure, okay? And then we also have, I'll say furniture. I usually name it furniture. It's basically other loads that are on the structure, and still a dead load. And then add, no. It should be, we can modify this one. This is furniture. Sometimes it will change, but you can correct it. Some problem with the keyboard. Okay, so furniture, instead of add, you hit modify here, and it will modify the case name. Next, we have earth, pressure, dry. Okay, why do we have this? It's also dead load because sometimes there is a case where everything is, or the water level is just below the base. So you're just dealing with earth, pressure, dry. Add. And then we have also wet. Okay, this is when the water level is just at the top of the wall, or you can say you will be assuming the maximum water level, groundwater level, basically. And then next is the searcher's load. These are the loads that are at the perimeter of the preliminary settlement tank. And this is definitely a live load. Don't mind about the label. This is not important. It will not affect the load combinations later on. Right. And then we have also hydrostatic. Okay, we need this hydrostatic to be able to check the uplift pressure. Okay, because stability wise, we have to check whether we do have some problems with the uplift. And this is also live. It's not adding. Okay, and last but not the least is the water, or so call it as sludge water if you're doing some water retaining structure. And then sludge, right? It's also live load. But so there you have it, the different load types. And then the next job will be to create the load combination. Okay,